day, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Mithala Chia. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Phakama Research and Development. Our main focus today, grade 12 learners, it will be data handling. I know you have already covered this topic in term 1. But now we will be focusing under the subtopic of representing and analyzing the data. Yes, grade 12, don't forget we have our WhatsApp number at the bottom of the screen whereby you can send your question, you can send a shout out to a teacher, or you can send a shout out to a classmate. Don't forget to give us your name, the name of your school for the shout out, and please, boys and girls, don't send us a video call. Don't call. Just send a message and then my assistant will attend to all your questions. Grade 12, yes, data handling. It's one of the topics in paper 1, which gives us more marks. If you can have it correct, this topic, I know you'll master it and then you'll have the marks for free. Here, what we have done in the past lessons, we have already covered the terminology of data handling, the biased questions, the categorical data, classifying of data. I'm not going to focus mainly on this terminology, but I know and believe that your teachers in class, they have already given you this terminology. You need to know them off by heart because they are examinable as we do the data handling. But for today, by the end of this lesson, you should be able to represent the summarized data using the appropriate graphs, like your box and whisker plots, your bar graphs, histograms, line graphs, pie charts, and scatter plots. You should be able again to draw the bar graph, histogram, and line graph. Read the summarized data from the graphs, analyze and interpret the summarized data presented in the graphs. Yes, boys and girls, remember when we started with data handling, we did analyze the questions, we did interview, and then we summarized the data that we got. So for our lesson today, the focus will be on representing and interpreting the data. So as you can see here, with data handling, we need to represent, analyze, and interpret the data for it to make sense to the people in the room, because you can collect the data and then it will be used. If you don't analyze it, they won't understand what is happening. So we have to represent it in a form of a graph. Once the data has been summarized, it is often useful to represent the data visual. There are types of graphs that we'll be doing, boys and girls. We are going to focus on our line graph, the bar graph, histogram, pie charts, scatter plots, and box and whisker, as I have already mentioned. But you know that the line graph, it's a graph whereby you plot the coordinates, the dependent and independent variables. So you plot them on your graph and then you join the points to draw a line. And then the next one, it's a bar graph. We know that with the bar graph, we have already done it. From grade 10, it's not new. The bar graph, it's a bar, it's a graph that has got bars with the same width and the spacing between the bars is the same. It's not that the other one will be slim and then the other one will be thick, but now it will be the same. And then what we do now, we have to check, okay, the only thing that will be different, it will be the height of the bars pertaining to the data given. And then we have the histogram. With the histogram, there is no spacing in between. So that means the bars are attached together. So if I can remind you that with the bar graph, it is a discrete data because it uses the whole numbers. So with a histogram, it is a continuous data. And then with a pie chart, it's a pie, it has segments divided according to the percentages. So that one, it's your pie chart. And boys and girls, remember, in the exams, you can be required to draw a line graph representing the information or the data that you have collected, that you have summarized. You can be requested to draw a line graph. You can be requested to draw a bar graph. You can be requested also to draw a histogram. But when it comes to the pie charts, this one, you don't draw it. But what you do, you just interpret the pie charts. And then the scatter plots as well. It's not always whereby they want you to plot the scatter plots. They will give you, and then you analyze and you summarize the data. With the box and whisker, that one we know we have been doing it, whereby now we have to summarize and interpret that. That one you will be given, and then all you need to do is to interpret it and analyze. Now, grade 12, boys and girls, these are the things that you need to remember as you do what? As you interpret your graph. Number one, the type of graph. Which graph is it? Is it a line graph? Or is it a bar graph? Is it a histogram? The ones that I have already mentioned. You need to know it. And then the graph title, the labels, the x-axis. So now you need to know, okay, fine. If it is a graph, then say suppose my graph might be looking like this. And then I know that here, this is my y-axis, and then this will be my x-axis. And now, because we are in mathematical literacy, we don't deal with the axis, but we deal with the independent. Here at the bottom on the x-axis, we say it is the independent data. And then here it is the dependent data. Like I have already mentioned, as you can see there, we have the dependent data, which will be on the y-axis, and then the independent data, meaning here it will be the y-axis, here it will be the x-axis or x variable. Now, the relationship between the variables, you need to know what is the relationship between these two variables, the independent and dependent. Sometimes the relationship, it can be a linear one, whereby when the independent increases, the dependent also increases. So it's one of the two. So the other one, it will be where one, if the independent decreases, then the independent increases. You need to know the relationship between the variables. The next one, it is the visual trends. The visual trends represented in the graph. What is it that you see on the graph? You must grade 12 be able to see the trend. There's a pattern that you'll see in the graphs that you need to summarize or that you need to interpret. And the reasons for changes in the graph. Why are there changes in this graph? Once you can understand what are the main reasons for the changes, and then you'll be able to get the marks in full. Yes, boys and girls, this topic is one of the easiest. This is where you are to collect the marks, because now you'll be only focusing on interpreting and analyzing the given information. Things to remember when you interpret the graph. Is there a missing information? Is there a missing information? If there's a missing information, that means that is the information that you'll have to look at. Do I have enough background information? Do I have enough background information to analyze this data? Because there's a missing information. Then do I have enough background information to analyze this data? Is there any extra or unnecessary data that is given? This is what you need to know. And then again, we say, based on this data, what can we project for the future, which is the probability? Remember, now we'll be looking at the data, we are interpreting, and then you have to analyze it. And then you say, okay, fine. Based on this, what I have just seen, or what I can see, what can I make out of this? What can I project now for the future? That is our probability. If things are going to go the way I'm thinking, according to the pattern of the graph, that I'm seeing? Or who could use this data or the graph? Is it meant for the people up there in Parliament? Maybe you have collected the information, the statistics, and then now you have summarized it. Now you want to interpret, you want to analyze it, you want to show them that according to this graph, look at this information. This is the number. For example, if maybe you want to tell them about people who are unemployed, then you will collect that data and then you will represent it according to the ages to say, look, maybe the age between the ages 18 to 35, there are more which are not working, which are unemployed. But as it goes down to the age of 15 to the 19, those ones, then we say, these ones, they are there, but because most of them, they're still at school, it's not that much. And then when it goes to the adults now, it is increasing. So you are able to draw a graph and then they'll be able to see, oh, this is what you mean. And then at the end of the presentation, then you have to make a conclusion about the graph to say most South African youth is unemployed based on what you have given them, what you have shown them on your graph. Now, boys and girls, we will be focusing on a box and whisker diagram. Remember, I have mentioned to say we have interpreted the data and then now we represent it on a box and whisker diagram. Now, before we can start, let's see. This activity was adapted from Western Cape, September 2019, paper 2. Remember now, here it is mentioned that it is adapted from paper 2, but now data handling, it's in under paper 1. It's no longer under paper 2. Yes, this information, because it was back then, before we could change the structure of the paper, whereby paper 1, we have finance and data handling with probability, 5% probability, and then paper 2, we have measurement, and then we have maps and plans with 5% of probability as well. Now let's have a look at this graph, boys and girls. If you have any question, don't forget to use the SMS number or the WhatsApp number at the bottom of the screen, which is 082-760-2630 to send your question. Now let's have a look here. Boys and girls, before we can even answer the question or before we can look at the questions, we have to analyze what we see in front of us. Here we are given the box and whisker. And then for us to have this box and whisker in a simple way, we check what is it that we have. We can represent this box and whisker or maybe analyze it with a 5-point summary or maybe 5-point number summary, the way your teacher has taught you in class. Now here we have our minimum value. Here it will be our minimum value. And then we have our Q1, we have our Q2, we have our Q3, and then we have our maximum value. Now, boys and girls, as you can see, it's a 5-point summary whereby we have the minimum, the Q1, which is quartile 1, and then we have the quartile 2, which is our median, and then we have the quartile 3, which is our upper quartile, and then the maximum quartile, the maximum of the data set. Now, boys and girls, if we can check here the bar graph, the box and whisker plot. This is a box. Here it is our box, and then these are our whiskers. And each whisker here, each segment, it is 25%. It is represented by 25%. So even here, it is 25%, 25%, and then also here is 25%. It means between the minimum value and the quartile 1, it is 25% of the data. And then between the Q1 and the Q2, it is also 25% of the data. Between the Q2 and the Q3, it is also 25%. Between the Q3 and the maximum, it is also the 25%. Now let's go back to our question. It says statistics were gathered from basketball players and baseball players to determine the distribution of their heights. The box and whisker plots below shows the height of basketball players and the baseball players in inches. So here this information, it's not given in centimeters, but it's now given in inches. Don't be scared that now why are they using the inches, because we are only used to the inches. Remember, grade 12s, we did the conversions whereby we're doing the metric and the imperial systems, the metric systems and the imperial systems. So the imperial systems, that's where they use the inches, and then the metric systems, we use the centimeters in terms of the height, centimeters or meters. So now here we'll be focusing with this one, it is under the inches. Now let's go through the questions. It says, number A, what is it that we need to focus at? Verify through calculations. So that means we need to verify through the calculations whether the difference between the IQR, the difference between the IQR of the basketball players and the baseball players is 3 inches. So there are two things that we need to look at. That means we have to analyze our first box and whisker for the basketballs and our second box and whisker for the baseball in order to answer that question. And then the next question, it says, what is the average height of the baseball players? Don't worry, boys and girls, we are still going to answer these questions individually. For now, I am just going through these questions. So it means for our number A, you'll see when we do it individually, then we'll be focusing at, okay, what is the IQR, which is meaning here it is our Q1, and then our Q2, our Q3. So now we'll be determining the IQR for the baseball and the IQR for the basketball. And then we say in mathematical literacy, the difference, we don't want to know whether the others are taller and then the others are shorter, but we want to know when we minus the IQR, the interquartile range of the basketball players and the interquartile range of the baseball players, then we subtract if it will give us 3 or not. That's what we are to verify with number 1. And then number 2, what is the average height of the baseball players? Remember, boys and girls, the average height. When we talk about the average, we talk about the mean. Yes, we are given here the box and whisker plot, but we can still identify the average height from this. We either calculate it or we can just spot it. If you are able to spot it, you give us the answer straight ahead, but it depends on the mark allocation. If the mark allocation, it says 3 marks, therefore you need to show the calculations. If the mark allocation, it says 1 in the exams, then you just spot, you just identify to say, oh, okay, this is my answer, and then that's it. You write it down. But you need to know, how do we calculate the average or how do we calculate the mean? And then number C, remember here we'll be focusing at the average. For number C, it says, if the data of 85 basketball players were used to draw the box and whisker plots, answer the following questions. So that means we are given the total number of population or the total number of learners of data that was taken from the basketball players, and then it was 85. Then what we have to do now, we have to analyze it and say, oh, okay, fine, I'm giving this. They're telling me that it's 85 basketball players were used to draw this box and whisker. And then now we have to calculate, number 1, the number. Remember, this data, it represents the entire 85 basketball players from here up to there. So now it's not only for one person, but it's for the entire data of those players. And then now we say, calculate the number of basketball players who are 79 inches and taller. We'll do that as well individually. I don't want to touch on this one because we're going to make our graph to be a mess. But now we'll see when we do it individually. And then number 2, a data analyst states that 75% of the baseball players are shorter than 50%. So it means it's 75% of the baseball players. We say they are shorter than the ones of the basketball, 50% of the basketball players. Now it says, a question says, validate this by referring to the quartiles of the different data set. So when you validate, it means we have to check. We have to see, okay, is it true or not what they are referring to? Boys and girls, I hope you have your calculators nearby, because a soldier can't go to war without a gun. So calculators is our gun in mathematical literacy. Like I have promised you, we are going to look at these individual questions now. Here we said we are using the 5-point summary. Now let's look here for our basketball players. For the box and whisker of the basketball players. It says verify through calculations whether the difference between the IQR of the basketball players, and baseball players is 3 inches. Now, before we can do that, remember I did make a mention of the 5-point summary. Now, let's see what is our minimum value for the basketball. I will write it from this side to say for the basketball, excuse my handwriting, you know, hey, it's so horrible, but you know the mathematicians, they don't have a nice handwriting. They always say our handwriting is so horrible. Now, let's see. What is here? We said we have our minimum value. And then here we have our Q1. We have our Q2. We have our Q3. And then we have the maximum value. Now, let's see. For our basketball players, what is the minimum value there? If we can check there, if I can do this, a slide 1 as a dotted, you can see our minimum value there. It is what? It is 67. So meaning our minimum value, using the 5-point summary, our minimum value, it gives us 67. And then we go to our Q1 now. Our Q1 there, it is our Q1, which is the lower quartile, it gives us 68. And then our Q2, which is the median, Q2, it is what? It is 74, and then 74 inches. And then our Q3, remember we said the 5-point summary, our Q3 here, it is 79. And then what is our max? Our max will be here. We check our max from here. It is 85. Our maximum is 85. This information now is for the basketball players. And then now when it comes to the baseball, but before we can even go to the baseball, remember now we have to find the IQR for the basketball players. Let's see what is our IQR. How do we determine our IQR? We said interquartile range is equals to Q3 minus Q1. And then what is our Q3 from the 5-point summary? From the 5-point summary, you see it is better to do that. Now, boys and girls, I am going to give you a minute or two for you to calculate or to determine this IQR for the basketball players and the IQR for the baseball players. When we come back, and then we'll do it together. I am giving you 2 minutes, starting now. Yes, boys and girls. Welcome back, boys and girls. We are still busy with our activity 2 there, whereby we're still busy with a box and whisker. We are interpreting now the box and whisker. Then our question was that you have to determine, or you have to calculate the difference between the IQR of the baseball players and the basketball players. Now, firstly, we are going to determine the IQR for the basketball players, as we have already done there. For the basketball players, we have calculated, we have summarized using the 5-point summary, so that you can see which one is the minimum, what is the value for the minimum, what is the value for the lower quartile, the median, the upper quartile, and the maximum. So we said when we calculate the IQR, we say Q3 minus Q1. So what is our Q3? Our Q3 there, it is 79. So it means it will be 79 minus. What is our Q1 from this data given? Our Q1, it is 80. Sorry, our Q1, it is 68. Now, boys and girls, like I said, you need to have the calculator nearby, because we can't go to a war without a calculator. Then we say 79 minus 68, it gives us and 11. So that means our IQR for the basketball is 11 inches. Now we have to determine the IQR for the baseball players. Let's have a look now for our baseball players. I will try to squeeze it maybe over here for the baseball. Then their IQR. Now, before I can squeeze it, let's have a look. I will try to write it here at the bottom. And then for the baseball players, our Q1, our minimum value there, our 5-point summary, our minimum value is 64. And then our Q1, which is the lower quartile, it is 66. And then our median here, which is Q2, it is 70. And then for the Q3, it is 74. And then the maximum is 76. Do we all agree, boys and girls? Yes, I know you got it correct, because I've shown you. This is way far easy, boys and girls. When you get this type of questions in the exam, please grab it with 2 hands and run with it. Don't say, no, I don't know. I've never done, or we have done the box and whisker in class. And ma'am has given us a lot of data, and then you have to draw the box and whisker. Yes, you have drawn the box and whisker in class, but now here we are interpreting it and analyzing. Now let's calculate the IQR for the baseball players. We said it's Q3 minus Q1. Now, what is our Q3 for the baseball players? Our Q3, we said it's 74. That will be 74. Yeah. And then our Q1 is 66. Now, let's see what is the answer there for the IQR, the one that we are determining for the baseball players. We say 74 minus 66. That gives us 8. That means it is 8 inches. But what is our question requiring? Our question doesn't require only us to calculate the IQR for the baseball players and the IQR for the basketball players, but it requires the difference between the IQR. And we need to verify through calculations. What we have done here, we have done our calculation. Now we want to verify if we'll get the answer to be 3 inches. Now we say the difference now. The difference will be the IQR for the basketball players, which is 11, minus the IQR for the baseball players, which is 8, and then our answer is 3 inches. So that means according to this information, it is correct. There is a difference of 3 inches between the basketball players and the baseball players. Are we happy, grade 12? Yes, I believe you are happy. Let's move on to the next question now. Remember, it's still a continuation of what we've started with. Now it says, what is the average height? Now we'll have to determine the average height. And remember here now, what is given for us? The average, which is the mean. We know that when we talk about the mean, we are talking about the average as well. But are we given any figures? Yes, we are given the figures because on our box and whisker at the bottom here is what we call our timeline. This is our timeline where we get the answers for our 5-point summary. Now, looking at this, boys and girls, it says the average height of the baseball players, not of the basketball players, but we'll be focusing at the baseball players. So you need to take this into note that the question comes from which side, from which box and whisker. Is it from the baseball players or is it from the basketball players? Don't assume. Look at the question first and then make sure that you answer based on the correct information. And then now we go back to our box and whisker. Remember, we have mentioned that here to say our minimum value here, it is 64, and then which is our minimum value. And before maybe I can even do that, let me just quickly remind you, yes, our minimum value is 64. Let me write it here so that you can see. We said our minimum value is equals to 64, and then our Q1, boys and girls, it is 66, and then our Q2, we said it's 70, and then our Q3, we said it's 74, and then our maximum value is 76 according to our box and whisker plot. So now for the baseball players, and then when we calculate the average, we know that the average, or when you calculate the mean, we say we add the sum of all the data set and then we divide it by the number of the data. Remember what I said to you. You look at the mark allocation in the exams, but you'll see what I mean. So let's start then. How many values do we have in our data set? The given one, we have 64 plus 66 plus 70 plus 74 plus 76. We divide it by what? How many are they? 1, 2, 3, 4, 5. We divide it by 5. And then now let's see what will our answer be. Yes, boys and girls, I hope you are sending your responses on our WhatsApp line, which is 082-760-2630. Don't forget to send us your responses. My assistant is waiting for you there. Is waiting for your questions. If you have some questions or a shout out with your name and the name of your school, the name of your teacher, so that we can say it on air, give you a shout out. Now let's continue. Let's go back to our question whereby we were calculating the mean. Now we say it is 64 plus 66 plus 70 plus 74 plus 76. The total is 300. Yes, boys and girls, I'm waiting. I know you've got the answer. I know you've got the answer. The answer is 350. I was waiting for you, but I can see, you are just listening, and then I hope you'll give me the answers. Now we said we divide it by what? We divide it by 5 because there are 5 numbers in our data set. So it is 70. So now meaning our mean, according to this information for the baseball players, it is 70. And if we go back to our box and whisker. Let's see what is our Q2, which is the median, or our mean is 70. So now, if you know, like I mentioned, that you look at the mark allocation, if it says 1 mark, and then you just go straight to your box and whisker, and then you identify, okay, because they are talking about the baseball, and then what we need to do, we need to identify the average or the mean, and then here it is 70. Then you've got your full mark. I hope you got it correct, boys and girls. Don't forget that, it's very important. Our next question, number C, it says, if the data of 84 basketball players were used to draw the box and whisker plots, or the box and whisker plot, answer the following question. They have now given us the number of the basketball players. This data, this box and whisker, it means it represents 84 basketball players. Now it says, calculate the number of the basketball players who are 79 inches and taller. So remember what I said earlier. I said each segment here, it is 25%, meaning here between Q1 and Q2, between minimum and Q1, it is 25%. Even here between Q2, remember here it is our mean, and then here it is our Q1, this is our Q2, this is our Q3, and then this is our max. Now we say between minimum and Q1, it is 25%. And then between Q1 and Q2, it is 25%. And then between Q2 and Q3, it is also 25%. And then between Q3 and maximum, it is 25%. It means this box and whisker is divided into 4 quarters, which in total they give us 100%. What is our 100%? It is the total number of the players in the data set. So boys and girls, I am giving you a minute or two, so that 2 minutes, so that you can go through this question and then you answer it. Don't forget to send your number, your question or your answer in our WhatsApp at the bottom of the screen. Yes, there's your 2 minutes. Do it, and then we'll continue. Welcome back, boys and girls. I know you have now managed to answer this question for me. Remember now, we said each segment here is 25%. Now we want to know, the question says, calculate the number of basketball players who are 79 inches and taller. Now we go back to our box and whisker. 79 inches, where is it from the basketball? It is on the Q3. Remember from our 5-point summary, that one, you must always remember it, because once you know your 5-point summary, it's so easy to interpret the box and whisker. We said the minimum is 67. Our minimum is 67, and then our Q1, it was 68. As you can see what I'm doing, I'm not just saying Q1 is, I go back to my box and whisker and be accurate. And then here now, it is 74. Our Q2 is 74. And then I go on and say our Q3 is at 79. Our Q3 is 79, and our maximum is at 85. This is our max. Sorry about that. Our max is 85. Now we are talking about 84 basketball players. Now, where is 79 inches? We can see that 79 inches, it is right at Q3. So that means we want to know how many basketball players are taller than 79 inches. So that means it will be 25% of the data given, which is 70. From 75, now we can simply say 100% minus 75%, which is, here we say, boys and girls, as you can see, I said 25% here of the basketball players is higher than, their height is higher than 79 inches. And then between here, between Q3 and Q2, it means these ones, they are between 79 and 74 inches, their height. And then between Q2 and Q1, their height is between 74 and 68. And then from Q1 to minimum, their height is at 67. So that means each segment, it has got 25%. Now here we are left with what? We are left with 25%. What we want to know, how many basketball players that are taller than 79 inches, which will be 25% of the data set. So for us to calculate that, we say 25% of 84, because we are given 84 as total number of the basketball players. We say 25% of the 84, and then that will be 25 over 100 multiplied by 84. Come on, boys and girls. I hope your answers are ready there. We say 25 divided by 100, and then we multiply the answer by 84, or we can simply say 0.25 multiplied by 84. That will also give us the same answer as 21. So it means there are total number of 21 basketball players who are taller than 79 inches, which is our Q3. Did you get that, boys and girls? Yes. Always when we interpret this box and whisker, don't forget that each segment here is in quarters. Quarter one, maybe it's 25, it's divided into 4 quarters, which is 25% each quarter. And then now each quarter, now it will represent between, now if say suppose this is not part of the question anyway, boys and girls, I am just asking you so that you know it in future. Now if I can ask you to say what percent of basketball players is higher or is greater than the 74 inches. Their height is less, or maybe let's say their height is less than 74 inches. What percentage is that? Then we go back to our data. We say, okay, 74 inches, it is on Q2. That means the rest from 74 going down here, it is less. That means it will be 25% and 25%. That gives us 50% of the basketball players. They are lesser than 74 inches in height. And then 50% is higher than 74 inches in height for the basketball players. That's how we interpret, as long as you know that each segment it is 25%, and then it's easier for you to calculate or to determine the total number or the percentage given. It depends on the question. You must just look at the question. Here they wanted the number, and as they've wanted the number, they have given us only what the total number of the learners, or the total number of the basketball players and their height in our timeline of the box and whisker, which is 84. And then now we have to determine the number of people. Now as we determine the number of people, so it will be 21 people who are higher than, their height is higher than the 79 inches. I hope we are still together, boys and girls, and I hope you are enjoying the lesson as I am starting to enjoy it, because, hey, you know, sometimes we think data handling is difficult, but it is not. This is where you must get your marks. Then let's continue with our activity. It says now, if the data of 84 basketball players were used to draw the box and whisker plot, answer the following question. Remember, we did a Roman figure 1 at the previous. Now we are focusing at Roman figure 2. It says a data analyst states that 75% of the baseball players are shorter. Take note of this one. They are shorter. So that means when you go back to your box and whiskers for the baseball and the basketball players, you need to check, okay, they are saying 75%, they are shorter than 50% of the basketball players. Yes, boys and girls. Now they say they want us to validate this by referring to the quartiles of the different data set. We have already done that, boys and girls. It's not the first time we're doing this. I've already mentioned, remember I said each quarter here is 25%, 25%, 25%, and also here is 25%. So meaning each quarter is 25%. Now what we want to see, what we want to determine, what is it that we must validate now? We say a data analyst states that 75% of the baseball players are shorter than 50%. Now let's go to the baseball players and see 75% of them. Where are they? Here they are, 75%. It is on Q3. This is our Q3. This is our max, Q2, Q1, and minimum. Now we say from this 75% of the baseball players are shorter than 50%. Here it is our minimum, Q1, Q2, Q3, and max. Now let's see. It says 75%. Where's the 75%? Here's our 75%, which is Q3. And then this Q3, it is right in line with what? With the 50%. Look at here. This is 50%, which is our Q2. So our Q2 here for the basketball, Q2 for the basketball. Our Q2 for the basketball is what? It is 74. That is our Q2. And then our Q3, which is the 75th percentile, 75th quartile then of the baseball. Let's see their figure. Sorry about that. For the baseball, And then we say they are what? For the baseball, we say they are at 74. That is their Q3. It is 74. Now, looking at this, boys and girls, looking at this, we say, oh, okay, the Q2 of the basketball players, it's 74 inches. And then the Q3 of the baseball players is also 74. That means this validates it is true. 50% of the basketball players, this 50% go in there. 50% of them, they are at a 50% of the basketball players, their height is at 75% of the baseball players. So it means the baseball players, they are very short because now they take only 50% of the basketball players with their height, whereas in the basketball players it's 50%, meaning 50% of them, they are having a height which is higher than, or which is higher than 74 inches. And then whereas for them, it's 75% of them having that height of 74 inches. Are we together, boys and girls? So that's what we look at. We validate, we look at this information to say, okay, fine. Based on our Q3 and our Q2 there for the basketball, there is the 74. So, and then it says Q3 here, it's 74 for the baseball, and then Q2 for the basketball, it is also 74. That means it is true. We have validated by referring to the quartiles of the different data sets. I hope you understood this, boys and girls, because this is one of the questions that whereby you need to check, okay, now the question wants me to compare the two data sets. It means it's not referring to only one data set, but it is referring to the two data sets. So you need to check that as you answer that question. Let's move on, boys and girls. A line graph. Remember, we said we are interpreting and analyzing the data based on the types of graphs. So with the information given, we started with the box and whisker. Now we are going to do the line graph. We said a line graph, it is a line whereby we plot the points, the independent and the dependent variables. We plot the points and then we join them to form a line. After that, we interpret and analyze what we see. Now let's have a look here. What is important? Remember when we started with our lesson, we said we need to have the topic or the title for the graph. We need to have the title. So always when you check, okay, is this one given a title? No, it's not given a title, but you can give it a title. We say, Jabu, this is the title for this graph. Boys and girls, it says the time that Jabu spent watching TV. That is the title of the graph. The time in minutes, or the average number of minutes Jabu spent per month watching TV. That is our title of the graph. And then here, now remember what I said. I said we have the independent variables and the dependent variables in our graph. So here on the months, it is our independent variable, and then here it is our dependent variable. Now we check that, boys and girls. We say, okay, fine. Now we have identified the dependent variables is viewing time in minutes. The viewing time in minutes, it is our dependent variable, and then the independent variable, it is the months which Jabu spent, maybe the entire year, from which month? From January up until November. Now let's have a look at this graph. As we can see, there's a pattern that we see on this graph. It's not just a straight line, but these are the points plotted, and then they are joined together to form a certain pattern. So that's what we are going to try and analyze. If you get this type of question in a graph, in an exam, don't panic. This is easy. What you just need to do, you just need to check, relax, and say, okay, fine. What is the information given to me? Where do I need to start now with the information, and then how to apply it? Here is our first question now. that we need to check. Remember, we said here it is the independent dependent. Now we start. It says, can you observe any trend? Can you observe any trend or pattern in the data? So when we look at our graph here, boys and girls, it's not a straight line graph. So that means there's a certain pattern. So now, can you observe any trend or pattern in the data set? Give some possible reasons for this trend. Yes, there's a trend that we can observe. As we can see, in January, Jabu has spent 108 minutes watching TV, and then the pattern, it decreases from 108 in February, and then it went straight to 103 minutes. Jabu was no longer spending much time in February in TV, watching TV. But now, from February to March, it started to increase. Now, it started to spend more time again. It started to spend time on TV, watching TV. Then it started to move from 108, from 102, 103 minutes, and then it moved straight back to 108 minutes. That's when he started to increase the time he spent on TV. Then from there, it went up again. It increases up until 120 minutes watching TV in April. Then from April to May, it decreases. As you can see, boys and girls, I'm not just saying from January to November, then the graph increases or decreases. No, I'm becoming specific because the question says, what trend or pattern do you notice from the given data? Then we say from March, it was at 108, it increased to 120 minutes. And then again, from now April going to May, it started to decrease now. It has decreased, it has went to 115 minutes in May. And then it started to increase again. It started to spend time again. And then to June. From May to June, it was at 122. And then from June, now things started to get serious. And then it started to decrease bit by bit. It started from 122 and then it went to 116. From 116, it decreased further. Now, can you see it decreased further to what? To 105 minutes. And then from the 105 minutes in August, so meaning in July, from June to July, he dropped, and then from July to August, he started again decreasing the time he spent on TV. And then from August to September, they started now to go back and watch TV. And then that means it has increased. But from September to October, it decreased again. And then from October to November, it has went down. But not as steep as it used to be, or not as steep as between September and October, just a slight decrease from 105 to 104. It decreased. So if we look at the pattern, there are possible reasons. Any reason that you can think of, boys and girls, please send it to our WhatsApp line, which is 082-760-2630. Look at it there, send your answers there, and then now we say, okay, fine, what could be the reasons? Maybe Jabu was studying. In January, we can say he didn't have a lot of work at school, so he could spend some time because it's the beginning of the year. But once he went back to school, if he's a learner, then he started focusing. Now he started to spend less time in books, and then he said, no, I'm managing. I am managing, and then he started to say, now since that I'm managing, I can spend more time. Or he doesn't have a lot of work to do, then he spends more time in watching TV. They spend more minutes watching TV. But now, from April to May, maybe he was preparing for the exams. you know, in March, because he was writing March, yeah, he didn't spend that much. And maybe from March to April, it were school holidays. That is why he spent more time. And then he comes back and say, okay, fine, now it's April, we are going back to class now. He spent less time now in April. From April to May, he spends less time watching TV. And then from May to June, he said, I know, now I've adapted. I can go back. Maybe now he was now watching this live podcasting lessons. He focused on TV, watching that, not watching the cartoons, but he was working. Now he was watching this video, the Maths Lit videos. So now I say, okay, fine, let's spend more time on TV, more minutes. But now from June to August, he had a lot of work. So that could be the possible reason that as he becomes busy, he spends less time in watching TV, and then he doesn't have more to sit around, you know, to do nothing. But if the work becomes less, and then he gets the time to watch the TV. So as you do these questions, boys and girls, you just check the trend. You give the trend per month. You cut it in bits and pieces, and then you analyze it per month to say from January to Feb, what is the trend, what you see, and then from Feb to March, what you see, and so on. That's how you analyze this information when you are given this type of graph. Let's continue, boys and girls. It says, what is the advantage of using a line graph to show this information? I can say here, it is a continuous, this graph, remember we are still under data handling. This graph, we can say it's a continuous, so it shows us the pattern. That is the advantage. It's a continuous graph, a continuous data, because it doesn't only specify just, you know, for 1 month and then that's it. Then it goes to another person. No, we are talking about the same Jabu. We are checking the trend that he is spending time on, or she is spending time on watching TV. So we are able to track it. We are able to see the pattern to say, when is Jabu focusing? When is she focusing on TV? Or when is she spending time on her books? So that is the advantage. It is more accurate, and because the data is continuous, we are able to have a full pattern of what we see. So here the advantage is that it is more accurate, and then it is having a continuous data from 1 month to the next one, because it is only using one person. It's a data from one person. They've been observing the pattern of one person. So that is why it is simple for us to say, oh, okay, this type of graph, the advantage that we can use the line graph to show this information is that it uses a continuous data. It doesn't use a discrete data whereby it is only per month, but maybe say for one person, for two people, but it's only for one person. So meaning it carries on, that pattern, it carries on from month to month. That's what they are observing. Boys and girls, we have now the bar graph. Remember, we did make mention of the types of graph that we need to analyze and interpret. We have already covered we have started with the box and whisker plots, and then we have done the bar graph. Now we have done the line graph. Now we are going to focus at bar graph. Now with our bar graph, still the same important information. Do we have the title of the graph? Yes, here's the title of the graph. And then now, do we have the independent variables? Yes, this is our independent variables. And then do we have the dependent? Yes, we have the dependent variables. But now look at this. There is something interesting. Our bar graph, here we have number of units sold, and then here we have the names now. No longer number versus a number, but it's a number of units versus the type of sandwich or the type of food that is sold at school. Now it says, the title of the graph here, it says the quantity of different items sold at the tuck shop. That is the title of the graph. Now it says the school tuck shop keeps track of how many hot dogs, sandwich, salads, and burgers they sell at one break time. remember now it says when at 1 break time. They are keeping track to say, okay, today, meaning every time as you go to the tech shop at school, they tick now, okay, what do you want? You say, no, I want a sandwich. Then they tick from the sandwich. That's the total number of sandwich that they have prepared. Every time you buy, you say sandwich, then they tick. Every time you say hot dog, they tick, 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 tick. Whatever that you will be buying as learners at that particular school. Now they say they have the data given in the graph alongside. Can you see this data given alongside? Now let's see what the question requires. The question says, explain why the data displayed on this graph is classified as categorical. Why is this data given on the graph? It is categorical. What did we say? What is the categorical data now? The categorical data, it is mentioned, it makes mention of names. It is not the numbers. As you can see here, we have the type of items sold at school. We have hot dogs. So if it's categorical, here we are talking about the food items that are sold at school. So it's hot dogs vis-a-vis the sandwich, vis-a-vis the salads and the burgers. So it means it is a categorical data. It is not the one of numerical, because we don't talk about the numbers here, but we are talking about the names. That is why we say it is the categorical data. I know you have done this, boys and girls. It's not for the first time you are hearing about the categorical and the numerical data set, as we have already done the discrete and the continuous data. To say the discrete data now, it is the data that is focused on the whole numbers, and then it doesn't have the decimals. But with a continuous data, remember now it's a continuous, there's an interval, it moves from one point to the other. So let's take, for example, it depends again on the information given under the context. You must read the question with the context to say, oh, this information, for example, let's take the shoe size. I can be size 6, somebody else can be size 6.5. It depends on the shoe size. That's when then we say, because now we are talking about individual people with their shoe sizes. Maybe say John is wearing size 2, and then Nontlanta is size 6, and then Jabu is at size 7.5. So as we can see, they are different. Some Jabu is having a 7.5, but that is specifically for Jabu. So in that context, we say the data can be a discrete data, even if it has a comma, because it talks about the shoe size. But if we can say how many people are in a room, if there is Jabu, Nontlantla, and then there is Charlotte, and then there is Owetu, you look at those number of people, and then you say, okay, this one, because they're talking about individual people, that means that is the discrete data. But when it comes to the age now, for the continuous one, today I am 17 years and 8 months. So it means I've got how many months remaining for me to become 18 years? I still have 4 months remaining. So it's an interval. It means I grow. It's continuous. I grow continuously. So I don't stop. So it will move from 17. Now it goes up to what? It goes up to 18. And then from 18, it will be 18.1, 18.2, 18 years, 1 month, up until I am at 19 years. So that is why we say that data, it is a continuous data. But for this one, for this particular graph that you are looking at, it is categorical, because we have made mention of the names for each category here. Let's continue, boys and girls. I hope you are still with me, and I hope you understand. You are able to identify, okay, the title of the graph. We are able to identify the dependent variables and the independent variables from the graph. And remember what I said about the bar graph. I said the bars here, they have the same width. As you can see, the width of this bar is the same as the width of this bar, is the same as the width of this bar, and the same of the width of this bar. And the spacing in between, if you look at the spacing here, is the same. This is how you plot. And this question, in the exams, you can be required now to do what? To answer, to plot or to draw your bar graph in an exam. So this one, it is questionable. They can require you to draw the bar graph, or they can ask you to do what? To interpret the bar graph given. Let's continue, boys and girls, with our bar graph. Now, remember we said it is a categorical data that is given here as we are focusing on the names. Now we look at the question again. It says, the school tuck shop keeps track of how many hot dogs, sandwiches, salads, and burgers they sell at one break time. They have the data given in the graph alongside. What is our question now? Remember, we have done the first one. Now we are doing the second one. What is the most popular food sold by the tuck shop? Boys and girls, remember what I said when I started. I said, when we interpret and analyze the graphs in data handling, it's so easy because you answer from what you are looking at. You don't even need to scratch your head to say, where would I get the answer? The answer is right in front of you, looking at the graphs. Let's see. Hot dogs. How many hot dogs did they sell at one particular lunch break? They've sold 15 hot dogs. And then for the sandwich, they sold 35 sandwich. As you can see here, for the sandwich is 35, for the hot dogs it's 15, and then for the salads they only sold 10 units, and then for the burgers they sold about 13 units, 13 units. That's what they have sold. But now our question says the most popular food sold at the tuck shop. By looking at the graph, here's our most popular with 35. Sandwich is the most popular item sold at that particular school, at that particular day, at that particular lunchtime. That's where they've sold most items as sandwich. Do we get that, boys and girls? So that means the question says they have given, okay, what is the most popular food sold by the tuck shop? So now we'll say the answer is sandwich. Sandwiches. That is what they have sold mostly during the break time. You see, boys and girls, how easy it is, because we are looking at the graph. You're saying, oh, okay, this one is the highest. That means that is the most items sold at that particular school on that particular day and on that particular lunchtime. Let's continue with this question. Now we are at question number C. How many food items were sold? How many food items? Remember, we said these are the items sold at the tuck shop. Different items. Now, how many items were sold? How are we going to determine the answer? To say how many items? Now you start by saying, we said hot dogs, there are about the total number. Let's try to write the answer here. We say the total number now of hot dogs sold, there are 15 hot dogs, plus the sandwich, we said it's 35 sandwiches, and then the salads, there are about 10 salads, plus here the burgers we have 10, and then we can safely say it is 12 burgers sold. As you can see, it is not right in the middle. If it was here in the middle, we would say it is 13, but now it is just below a bit on the middle, then we say it is 12. Now we want to know how many food items were sold during that break. So let's do the calculation, boys and girls. I hope you are having your calculators in front of you to do this work with me. Let's start adding. We say 15 plus 35 plus 10 plus 12. That gives us 72 items sold. Do you agree with me, boys and girls? Yes, it is 72 items sold on that particular day at that school. Those are the food items that they have sold. Can you see how easy, boys and girls? Because what I have done, I have gone back here. I've looked at the number of items. That's where I was able to get the total number of the items sold per unit. Now look here, it says number of items, number of units sold. So it gives us the number. Then we are quick to identify, okay, from here, 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 and right here. It's easier for you to be able to identify. Can you see how it's easy to interpret the bar graph? It's not difficult at all, boys and girls. That's what you need to do. Focus, look at the graph given, and then you are able to answer. Now, looking at this one, boys and girls, here we are given the multiple vertical bar graph. Now with this one, why are they calling it a multiple vertical bar graph? This graph is vertical because, as you can see, it's facing up. If we say it's vertical, it's facing up, and then the horizontal one, it goes this way. So this one is the horizontal. This one is horizontal, and then this one is the vertical. So going up, it's vertical, and then going this way, it is horizontal. So now what are we given here? Here is just for you to be able to identify. Why is it a multiple vertical? Multiple because we have the information about Western Cape, Gauteng Province, also Eastern Cape and KwaZulu-Natal. So these are the number of cases at each and every single province mentioned. And how do you know? Because it has been identified by colors here. As you can see, they will tell you that the Western Cape, it is blue, and then the Gauteng, it is orange, and then Eastern Cape is gray, and then KwaZulu-Natal is yellow. So now what they have done, remember they have collected this data on different dates. So on the 28th, from these provinces, from the four-mentioned provinces, this is the number of cases that have been reported. And then you go to the next date on the 21st of May. These are the cases reported per province. And then you go on the 14th again. This is the total number of cases per province reported. So it's easier when you do the multiple vertical bar graph. Don't say, now I don't know how to answer this because there is more bar graphs. Yes, it looks like it is a histogram, but it's not a histogram here because it's not a continuous data. What you see here, it's an individual province with its individual numbers. So the data for Western Cape is not the same as the data for Gauteng, and it's not the same as the data for Eastern Cape and also for KwaZulu-Natal. So each bar, it represents a province. So when you answer this type of question, you look at those keywords to say, okay, this bar, this stack of graph, or this line, this category, it represents which province. Okay, it represents this. Then if a question arises, they might ask, what is the total number, or how many cases were reported at Gauteng on the 14th of May 2020. Now you go straight to your data now. They say how many cases, COVID cases, were reported at Gauteng province on the 14th of May. Then I go to my data. Okay, here's 14th of May, and then now I look at, oh, okay, they're asking about Gauteng. Gauteng is number 2. It means there are 2,135 cases reported were at Gauteng. And as we look at the graph there, it shows, okay, here is our Gauteng. Oh, sorry, this is our KZN. So our Gauteng is here, yes. Here's our Gauteng here, boys and girls. So Gauteng, it is 2,135 cases reported on the 14th of May. So that means this data that is given here, it is a discrete data because it's not a continuous one. It doesn't carry over. It is the number of cases reported on that particular day. Boys and girls, I hope now you fully understand when you talk about the types of graphs, especially when it comes to the bar graph. We have the vertical bar graphs, and then the vertical bar graphs, which are these bar graphs that are standing like this, and then we have the horizontal one. The horizontal one, it will be a bar graph standing like this. This is our horizontal bar graph. So always the information is the same, it doesn't change. What you need to do, you need to look at the question and then analyze it, answer based on what has been asked. I hope we are still together, boys and girls. Let's move on to our next question. Now we are doing the next stack bar graph. Remember, we have done the bar graph, we have done the line graph, and then we have done multiple vertical bar graph. Now we are doing a stack bar graph. Now, as we are doing the stack bar graph, boys and girls, let's have a look here. Here we are being shown the recoveries and the total positive cases. So on each particular day, on the 21st, 14, 7, 30, and 23rd of April 2020. So we can see there are total positive cases. This information, it correlates with what we see here. This information is the same as what we see here. It's on a weekly basis. As you can see there, these are the number of cases, and then these are the number of weeks. So as you can see here again, these are the number of weeks. It's week 1, 2, 3, 4, 5. Now we look at this and then you say, okay, fine. These are the cases reported, and then these are the recoveries from the cases. Now with the stack graph, the orange part, this part that you see here, it means it is the recoveries on that particular day, not for the entire, because remember we said it's not a continuous data, it's a discrete data, so it will be based for that particular day, boys and girls. So our question here, it says, use the table and graph below to answer the following questions. Is the data displayed in the graph a discrete or a continuous one? We said it is a discrete data because it represents the data for that particular day. It doesn't carry over to the next week, but it's only for that particular week. So it is a whole for that week. It shows us the number of the cases and the recoveries for that particular week. And then number 2, it says approximately how many recoveries were recorded in week 5. So you look at week 5. Here is our week 5. And then now in our week 5, here it is our recoveries for the week 5. Now for you to answer this question, boys and girls, you start by checking here. What is the minimum here? It's at 0. And then it's from 0 up until, say, roughly at just below 30,000. And then now we want to know how many recoveries. Then you will take, okay, fine. The total cases, it's up to where? The total cases is up to here. So it means you'll be checking from here, from this side, to say, okay, if this is the total number of cases, and then what is the difference? You will take, okay, from here, from 0 up to here, what is the total? And then from here, from the total from here, from the upper one, from the 20,000, starting with the recoveries going up, how many are they? And then you get to tell, okay, fine, if the distance is, say, 30, let's take for argument's sake, the total number of cases, or the total number of the positive cases and the recoveries for that particular week, say it is 29,000. Let's say it's 29,353. It's just an example, 29,353. And then what we do now, we say, okay, since it is 29,353, now the total positive cases, it ends at 20,000. We minus the 20,000. And as we minus the 20,000, what is our difference now? It will be 9,353. That means here we said it is 20,000. Here it will be 9,353. That's how you interpret these questions, boys and girls. It's so easy. And then the next one, it says, give 2 ways that may be used to prevent the spread of COVID-19 disease. Remember what I said, boys and girls. We interpret the data and we analyze it. And then as we analyze it, we have to give reasons now. What could be the reasons for this? Or what are the ways which we can use to prevent the disease? So there are two ways we can say: we wash our hands, always we sanitize, we wear our mask when we are out in the public. But now, since the COVID-19 rules and regulations have changed, it says if you are inside this the building, you have to put on your mask, but when you are outside, you don't have to put on your mask. But for our safety's sake, you know, we are so used to the putting on the mask. You can always put your mask, but you know, we maintain the social distancing, we wash our hands, and then we put on our mask. You can sanitize or wash your hands for about, what they said, for about 5 minutes, 5 seconds, I think. So yeah, for about 5 seconds, you wash your hands with soap, and then for about 5 seconds, and then you know that we will be defeating the COVID-19. Now, boys and girls, we are doing the histogram. We have done the bar graph, we have done the box and whisker, we have done the bar graph, we have done the line graph. Now we are focusing at the histogram. Remember what I said about the bar graph. I said the bar graph, it is a discrete data because it only represents that specific, the bar represents the data for that specific time only, for that specific week or whatsoever, for that category only. But now with the histogram, it is a continuous data. And as you can see here, it says it starts the length of books from 20 to 23,9, and then from 24 to 26,9. That means it's continuous now. It doesn't stop only at 20 to 24, 20 to 23, but it says 20 to 23,9, and then it continues to 24, from 24 to 26,9. So it becomes a continuous data. Now it says Luanda measures the length of his school books in centimeters and draws up a frequency table and histogram alongside. He has measured the length of his school books and he draws up a frequency table alongside. Here's our frequency table, and then he also draws a histogram. Here is our histogram. Now state the modal interval. So the modal interval, now we are looking at this now. The modal interval, it is from 24 to 26. Remember, modal, we said it's the number that appearing mostly. So now they want to know the interval. They don't say what is the frequency. Now they want to know the modal interval. They are not talking about the frequency, but they're talking about the interval. So the correct answer here, it will be between 24 and 26.9. That is our modal interval. 24 to 26.9 centimeters. Now, how many books were measured? How many books were measured? This one, boys and girls, it's so simple. We go straight to our frequency table. We just add these figures now. We say 7 plus 3 is 10, plus 5 it's 15, plus 4 it is 19. So it means it will be 7, it will be 4 plus 7 plus 5 plus 3, that leaves us with 19. So that means Luanda has measured 19 of his books or of her books. So that is why we say this information, it is a continuous, because all these books, they belong to Luanda. It's not for Luanda and Nonhlanhla, but they are all for Luanda. The next one now, boys and girls, the pie chart. I am trying to cover as much as I can with regards to the types of graphs that are examinable in the grade 12 exams for data handling. Now looking at this, remember what I said, bar graph, you can be requested to plot it in the exams. Line graph, you can be requested to draw. But now when it comes to the pie chart, we are not going to be requested to draw the pie chart, but we will be requested to interpret the pie chart. Now it says the pie chart alongside shows a survey of different types of favorite fruit juice flavors that are normally bought by a group of 120 learners from Royal High School during their lunchtime. So there we have different types of fruits with their different, remember now, a pie chart, it's a pie and then it is divided into segments. Those segments, they form a part of a whole now. So if I add all these parts, if I add the 45%, I add the 12.5%, I add the 12.5%, I also add the 12.5%, I add the 30%. If I add all these numbers, they are going to give me 100%. They will give me 100% because a pie, it forms a whole number. So it becomes, so this means this fruit cocktail, lychee, grape, and apple, they're the part of the segment. So that is why we say, oh, okay, fine, with a pie chart, it has its own slide there. Now, let's go to the questions. It says, calculate how many learners choose each type of juice. Calculate how many learners. And if, boys and girls, I can just remind you, remember here, they said to us, how many learners, the data was taken from how many learners? It was conducted from 120 learners. So meaning they have collected this data from 120 learners in a school. Now we want to know, calculate how many learners choose each type of juice. We start with number 1. We said, let's take this one, the blue one, fruit cocktail. For a fruit cocktail now, it's 45%. We say it will be 45% of what? Of 120. Because now they want to know how many learners, not the percentage, but how many learners. That will be 0.45, 45%. It is 45 divided by 100. And then we multiply it by 120. That will give us 54 learners. And then for lychee, now for lychee, let's look at lychee. Lychee is 12.5. We say 12.5% of 120. Okay, fine. We say 12.5% of 120, boys and girls. And then we quickly calculate what is 12.5% of 120. I hope you are still calculating with me, boys and girls. It gives us 15 learners. And then we move on to the grape now. The grape also, it is what? The grape is 12.5. So quickly, it's 12.5% multiplied by 120. That will also give us 15 learners. And then the last one being the apple juice now. With the apple juice is 30%. We say, okay, fine. What is 30% of 120? Which will be, remember, when they say a percentage, when they say 30%, it is 30 over 100. So what is 30%? It will be 30 divided by 100 multiplied by 120. That leaves us with 36. So meaning per type of juice, there is 54 learners choosing what? Choosing the fruit cocktail flavored juice. And then 15 learners chooses lychee. And then 15 learners chose grape. And then about 36 learners chose what? An apple. And if we can add all these values, they must give us what? The 120. So let's quickly verify if it will give us even though it's not a question, but for you to make sure that you have the correct information, you do that. You say, okay, fine. That would be 54 plus 15 plus 15 plus 36. That leaves us with 120. Remember, when we started by adding the number of segments. Here, the number of each segment in a pie, and then it gave us the answer. Now, in what ways? The next question, it says, in what ways does the pie chart work better than a bar graph to represent this data? Now, remember, with the bar graph, we are able to identify per segment, and the data there, it's not a continuous one. But here, the data is what? It's continuous, and then here it forms a whole, and then it doesn't give us that specific. It forms a whole now to say, okay, fine, 45% of the data choose this, and then 15, 12,5, 12,5, and so on. They each chose. Now, what you need to do, learners, remember, as you interpret these questions, it's very important. Go back to your lesson that you have already done in class. Know that when we analyze and interpret the graph, what we do, what we focus at, we look at the information given, and then from that information given, you start taking it bit by bit. Don't calculate or don't interpret or analyze the information at once. Cut it into segments and say, piece by piece, this is what I have, this is what I see, this is what is required, and then I will have to answer based on the relevant information. Thank you for watching this lesson, learners. I hope you have enjoyed as I have enjoyed. Remember, now I have even forgot that it is the end of the lesson, the way I'm enjoying myself. I hope you have also enjoyed. What you need to do, as we are now going to end our lesson, I hope to see you again next time with another lesson of our mathematical literacy. Thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distancing, and keep safe. See you next time. Goodbye.